Hi there and welcome to another video for the Edexcel Further Pure 1 Maths A-Level syllabus. In this video we work through the past paper questions that have arisen on coordinate geometry. As always, take a look at the question, pause the video, work through it yourself and then mark your work against my solutions. Let's start. Okay, we are told for the first part that we have a rectangular hyperbola h that has equation xy c squared and c is a positive constant, so c is bigger than 0. The point A on h has x coordinate 3c. Write down the y coordinate of A. Well, firstly, draw yourself a quick sketch. We know rectangular hyperbole looks something like that. And we are looking at the point A that has coordinate 3c. Now, c is bigger than 0, so 3c would be somewhere like here. And the question is, what is the y coordinate? Well, simply substitute x is 3c in. We have our equation xy is equal to c squared. We know that x is 3c lies on the curve, so you can substitute 3c multiplied by y is equal to c squared. Divide both sides by c. Y is equal to c squared divided by 3c, and we can cancel a c off top and bottom, and therefore y is equal to c over 3, or c divided by 3. Okay, next part. Show that the equation of the normal to h at A is this. Now, I'm just going to go back here and take our picture with me. So here's our picture. We now know the coordinate, the y coordinate there, so I'm just going to write that in. We know that the y coordinate at 3c is, we've said, c over 3 now. And we are asking the equation of the normal at A, at this point A. Now the normal, you'll remember, looks something like that. It meets this curve at a right angle to a tangent there. So I'm going to draw the tangent in, but we want the normal. Now for any point on a line, you need, for the equation of the line, you need a point on the line and the gradient of the line. Okay, so we've got a point on the line N, we need the gradient. So let's work out the gradient of the normal. Before we do that, let's work out the gradient of the tangent. We know that xy is equal to c squared. Rearranging, y is equal to c squared divided by x. And in index notation, this is equal to c squared x to the power of minus 1. dy by dx, therefore, bring down the power and reduce the power by 1, it would be equal to negative c squared x to the minus 2. And dy by dx would therefore be equal to negative c squared over x squared. Now, we want dy by dx at the x coordinate 3c, so we're going to substitute that in. Dy by dx would be negative c squared over 3c all squared. And that would be negative c squared over 9c squared. The c squareds would cancel, and you get negative a ninth. Okay? Right, I'm going to, therefore, I'm just going to shrink this a little bit here. That's the gradient of the tangent to the curve. Now, I actually want the gradient of the normal. Now, you should be working down the page, not across, but here I'm just running out of space. So I'm going to work over here in a separate section to work with the normal. You should work down the page. So the gradient of the normal is the negative reciprocal of this. So it must be equal to 9. And you know a point going through the line, you know a point 3c c over 3. So you use the formula y subtract y1 is equal to mx subtract x1. So y subtract c over 3 is equal to 9x subtract 3c. Multiply everything through by 3 to remove this fraction here. You'd have 3y subtract c is equal to 27x subtract 3c. Multiply out. you would have 3y subtract c is equal to 27x subtract 81c, and add c to both sides. 3y would be 27x subtract 80c, and you're done. That is the answer you're looking for 5 marks. Next, the normal to h at A meets the curve again at the point B. Find in terms of C the coordinates of B. Now, looking back at the previous picture, we knew this was going to happen anyway. We had drawn a picture, and what we're told, here's our picture, I'm going to just leave our picture here. We're told that the normal at A meets again at B, meets the curve again at B. So this point here is our B. The question is, what are the coordinates in terms of C? Well, what do we know? We know the equation of the normal. The equation of the normal from the previous part is 3y is 27x subtract 80c. So the equation of the normal is 3y is 27x subtract 80c. Well, what's the equation of the curve to start with? Well, the equation of the curve is xy is equal to c squared. So we have two equations, and we're going to solve them simultaneously to try and find where they cross. Now we know we're going to find one answer here is where they cross, and we need to find the other answer here, which we don't know. Now how could we solve these? Well, we could simply do a substitution, because from, let's say, from 2, y is c squared over x, and we could sub in 1, and we would get that therefore 3 c squared over x is equal to 27x subtract 80c. And what we could do is we could multiply everything by x to remove the x on the bottom and expand this bracket. We'd have 3c squared would be equal to 27x squared subtract 80cx. And then we could subtract 3c squared off both sides, so 0 would be 27x squared subtract 80cx subtract 3c squared. Okay? Now, that's a quadratic in terms of x's, isn't it? Because you've got some lots of x squared, some lots of x's, and just a number there. Now, if you think about this, you know one of the solutions. You know that x is equal to 3c is a solution to this equation. So x subtract 3c must be a factor. So if we were trying to factorize this, we know that x subtract 3c must be a factor. What needs to go here to multiply by this x to get 27x squared? Well, 27x. Okay, and when you do that, and then you multiply this, the 27x by negative 3c, you get negative 81cx. You don't want negative 81cx, you want negative 80cx. So you're going to have to add a cx. So therefore, if you add a c here, then this will add the cx you want, because that times that will add cx, and then the negative 3c multiplied by c will give you the negative 3c squared. So we know this was the coordinates of A, so we're not interested in this anymore. If we've got 0 is equal to this times this, well that's 0, well we know that, we use that, or this is 0. So on the other hand, 27x plus c is equal to 0. So 27x is equal to negative c, and x is equal to negative c over 27. Now, if we want to find y in terms of that, well, we know that y is equal to c squared over x, which is c squared divided by, is divided by x, which is negative c over 27. And if you flip that fraction and do the division, you would get that C is therefore equal to negative 27C. And these are our pair of coordinates here. X is this, and Y is equal to this. And we'd be done. Right, next question. Right, we have a rectangular hyperbola H which has equation xy is equal to c squared, where c is a constant. The point P, ct, c over t here, this is a parametric form of a point on the line. It's on H. Show that the tangent to H at P has this equation. Well, let's draw a quick sketch. A rectangular hyperbola always looks something like this. And a point on the line P, I'm just going to call that a point on the line P, and it's got coordinates CT, C over T. P could be anywhere, but let's just call it there. And we want to find the equation of the tangent to that curve, so the equation of that line there that goes through P and touches the curve at one point. So, for the equation of a line, we need a point on the line, which we've got. So, point on the line, point on the tangent, what we know easily is CT, C over T, and we need the gradient of the gradient. So, the gradient of T. Well, let's find the gradient by differentiating. The gradient of the tangent is the gradient of the curve at that point. So, xy is c squared. We know that y is equal to c squared over x. dy by dx, you should be able to do this in one move, would therefore be negative c squared over x squared. And dy by dx, at the point ct, therefore, at the point x is equal to ct, you substitute ct in here, will be negative c squared over ct all squared, and you get yourself negative 1 over t squared. Now you should work down the page, not across the page, but I'm just going to do it here so it fits in. That's the gradient of the tangent, so the gradient of the tangent is negative 1 over t squared. So use the formula y subtract y1 is mx subtract x1. Substitute in our point on the line, x1 is ct, y1 is c over t, and substitute our m is negative 1 over t squared. So y subtract c over t is equal to negative 1 over t squared, x subtract ct. Multiply everything through by t squared to remove the t squared on the bottom here. You'd get t squared y, and c over t multiplied by t squared will be negative ct, would be equal to negative x subtract ct. Expand this bracket here, we would have t squared y minus ct is negative x plus ct. And we could add ct to both sides and add x to both sides. That would bring a positive x here and 2ct here. So we would have t squared y plus x is equal to 2ct. And that is exactly what we're after for our 4 marks. Okay, next, part B. The tangents to H at the points A and B meet at this point 15C, negative C. Find in terms of C the coordinates of A and B. Right, we need a sketch for this, another sketch. So, here's our hyperbola here. And we know that the equation of the hyperbola is xy is equal to c squared. We also know any point on the line is ct, c over t. Well, we're told that the tangents at point A and B meet at this point. Now, A, we haven't been told A or B, so let's just pick a point. Let's show where this point is. 15c, negative c. Let's assume c is bigger than 0. So 15c, negative c would be 15c across and negative c down. So it might be somewhere like here, right? So that's 15c across and a negative c. Now tangents to the curve meet at that point. The tangents must be something along these lines here, something like that, okay? And something quite extreme from this point, something like that, okay? They must be the tangents, and I'll just colour them in a different colour if it makes it easier to see what's going on here. Okay? Now, we know from part A, look back at part A, the equation of any tangent. The equation of any tangent, we were told, is t squared y plus x is 2ct. So we know it's t squared y plus x is equal to 2ct, right? Now, we also know that's the equation of any tangent. Now, both these tangents go through the point 15c negative c. So we could substitute the pair of coordinates x, y is 15c negative c in here because we know both those tangents go through that point. So let's substitute in. T squared y, which would be negative c, plus 15c would be equal to 2ct. And multiply that out, that's negative ct squared plus 15c is equal to 2ct. Add ct squared and subtract 15c from both sides, so we have a quadratic. 0 is ct squared plus 2ct subtract 15c. Now we could divide everything through by c here. There's a c factor here. Divide both sides through by c. 0 is equal to t squared plus 2t subtract 15. And now we can factorise. This factorises very nicely into t plus 5, t subtract 3. So therefore t must be negative 5 or t is equal to 3. And we know t now. So therefore we know we can work out these 2 points, and that point there might be A and that point there might be B. We know that for this line t is one of the two, negative 5 or 3, and for this line t is negative 5 or 3. So we can substitute t into our formula. We also so a point on the line, we remember that a point on the line is given by ct c over t. So therefore, A, let's say, is when t is 3. So A, you substitute 3 in here, it would be 3c, c over 3. And B would be where you substitute negative 5 in there, and it would be negative 5c, and it would be negative c over 5. And then you'd be done. Okay, next question. Right, for the first part, we've got a rectangular hyperbola and we've got the parametric forms here. The Cartesian equation of h in the form x, y, c squared, write it in that form there. Well, we know that x is equal to 5t parametrically and y is equal to 5 divided by t. We've got two equations. So what we could do is from, let's say, 1, these are equations 1 and 2. This one tells me that t is therefore equal to x divided by 5. And so therefore y would be 5 divided by t, which is this. So 5 divided by x over 5. Y is therefore 5 multiplied by 5 over x. So y is therefore equal to 25 over x. And it wants it in the form xy is c squared. So multiply both sides by x. xy is therefore 25, which is equal to 5 squared. And you're done. It then tells you that points A and B on the hyperbola have parameters t is 1 and t is 5 respectively. It says find the coordinates of the midpoint of AB. So here is our rectangular hyperbola. And we know that xy is equal to 25. We're also told that t is 1 and t is 5. So here, xy is c is equal to 5, we said. Now, any point on the line is x is 5t and it's 5 over t. So when t is 1, so any point on the line is, 5t, 5 over t. So when t is equal to 1, the coordinate for A is 5 and 5, and when t is equal to 5, the coordinate for b is 5 times 5, which is 25, and 5 divided by 5, which is 1. Okay, so here are our two coordinates here. 5, 5, let's call it there, 5, 5. And the other coordinate is 25, 1, which is, let's say, somewhere like here. 25 across 1. It says find the coordinates of the midpoint of AB. So here's a line between A and B. Let's find the coordinates of the midpoint between A and B. Well, that's very simple. What's halfway between 25 and 5 for the x-coordinate? It would be 5 plus 25 divided by 2, which is 30 divided by 2, which is 15. For the y-coordinate, it would be 1 plus 5, or 5 plus 1 divided by 2, which is 6 over 2, which is 3. So the midpoint is simply, therefore, 15, 3. And it's as simple as that. Okay, next, try this one. So we're told we have a parabola C is equal to parabola C has the equation y squared is 20x. Verify that that point is on the curve. Well, this is simple. All we've got to do is substitute that in as an x, substitute that in as a y, and show both sides are the same. So, y squared would therefore be 10t all squared, which is 100t squared. And that would be your left-hand side. The right-hand side, well, 20x is 20 multiplied by 5t squared, which is also 100t squared, which is the right-hand side. The left-hand side equals right-hand side, so therefore P is on the curve, is on C. Simple. So just substitute x in here, find out what that side equals, substitute y in here, find out what that side equals. If they're equal to the same thing, then that point must be on the line. And then it says the point A on C has parameter t is 4. The line passes through A and also passes through the focus of the curve. Find the gradient of the line. Okay, let's draw ourselves a picture. So, we have a curve y squared is equal to 20x. So, y squared, let's write it here actually, y squared is 20x. In the form 4ax, we know that the general form is y squared is equal to 4ax. So therefore, that tells us that a must be equal to 5. So we've got ourselves a parabola, something like that. We've got ourselves our directrix here. And the equation of that line is x plus 5 is equal to 0. And the focus here must be the coordinate 5, 0. Now, it tells us that a point on the curve has parameter t is 4. So when t is equal to 4, we know that any point on the line is 5t squared 10t. So when t is equal to 4, the point on the line, which is 5t squared 10t, the point on the line would therefore be t squared would be 16, and 16 times 5 would be 80, and it would be 80, 40 would be our point. So we've got some point over here which is 80 across, 40 up. So let's call that point A, 80, 40. It says the line L passes through A and also through the focus of C, find the gradient. So we've got this line L and it's going to go through like that, and we're asked to find the gradient. Well, the gradient is a simple thing here. The gradient of any straight line is the difference in y's over the difference in x's. So here the difference in y's will be 40 subtract 0 divided by the difference in x's, which is 80 subtract 5. And 40 subtract 0 is 40. 80 subtract 5 is 75. And if we simplify that, that would give us 8 over 15. And we're done. That is the gradient of the line. Okay, next question. Okay, we're told that a parabola C has equation y squared is equal to 16x. Verify this point is on the line. So, i.e., verify that x is equal to 4t squared. If I substitute that in, what it will, and I substitute y is equal to 8t in, then both sides of the equation will be equal. So if I did that, what would the left-hand side be equal to? Well, the left-hand side would be y squared, which is 8t squared, which is 64t squared. What would the right-hand side be? Well, the right-hand side would be 16x, which is 16 multiplied by 4t squared, which again would be 64t squared. Left-hand side equals right-hand side, therefore P is on the curve C. Simple as that. Okay, write down the coordinates of the focus S of C. Well, we're told that y squared is 16x. Y squared is equal to 16x. We know the general formula of a parabola is y squared is equal to 4ax, and that's given to us in our formula sheet. Okay, so simply, therefore, 4a must be equal to 16, so a must be 4, and we know the focus, again told on our formula sheet, is a0, so the focus must be 4, 0. Probably appropriate now to just have a quick sketch of the curve. We know the focus is at 4, 0, and the curve would look something like this. And it would have directrix out of interest, x plus 4 is equal to 0. So it would have directrix, let's do that in a different colour just for a change. It would have directrix x plus 4 is equal to 0. And that's what the curve would look like. It says show that the normal to C at P has that equation. So I'm going to actually just take this and use it for future pictures. It's always good then when drawing tangents and normals to have the picture. Now, what was point P? We're working out the normal to the curve at P. P is any general point, 4t squared, 8t. So I'm just going to call this point here P. And P is 4t squared, 8t. And we want to work out the equation of the normal. So a tangent to it would look something like that. The normal to it would look something like that. And we want the equation of this normal. So I'm going to call that a tangent and I'm going to call that a normal. To work out the equation of any line, you need its gradient and you need a point on the line. We luckily have an xy point on the line, n there, but we need the gradient of n. To get that, let's work out the gradient of t by differentiation, and then we'll get the gradient of the normal as it's its negative reciprocal. So, the equation of this is y squared is 16x. So y squared is equal to 16x. So therefore, y, taking square roots of both sides, will be a plus or minus 4 square root of x. I'm square rooting both sides, which would be plus or minus 4x to the half. Now I'm just going to take the positive square root. I've chosen p to be up here, so I'm just going to take the positive one here. So y is equal to 4x to the half. Differentiating dy by dx. Bring down the power of half and reduce the power by minus 1. So it would be 4 multiplied by a half, x to the half minus 1, which would be 2x to the minus a half. And we want to work out, which converting back to square root form maybe might be easier, which would be 2 over the square root of x. So that's our dy by dx. Now we want dy by dx at a special x point, i.e. 4t squared. So dy by dx when x is equal to 4t squared. Substitute that in, 2 over the square root of 4t squared. The square root of 4t squared is 2t, so 2 over 2t is 1 over t. Now, you should work down the page, not across, but I'm doing it here so it all stays on one page. So I'm just going to make all of this a little bit smaller. Okay, so that's over here. That's where we're trying to get to. So that's our gradient of the tangent. Therefore, the gradient of the normal, m for the normal, is the negative reciprocal of 1 over t. So it's negative t. So let's use the formula y minus y1 is mx subtract x1. So y subtract 8t is equal to m, which is negative t, x subtract 4t squared. Okay, multiply this out. Y subtract 8t would be negative tx plus 4t cubed. And then add tx to both sides and add 8t to both sides. Y plus tx would be 8t plus 4t cubed. And you have got exactly what you want for the 5 marks. Okay, next part. It says the normal to C at P meets the x-axis at the point N. Find the area of the triangle PSN in terms of T, given your answer in simplest form. Let's just take this picture over. Very important to have this picture to help us understand what's going on. So, here's our picture. The normal to C at P, this normal here, meets the x-axis at the point N. This here is where it meets the x-axis at the point N. Find the area of the triangle PSN, where S, what's S? Going back to our original, I think S is the focus, we're told. The focus S of C, so S is the focus. Find the area of PSN in terms of T, given your answer in its simplest form. So we want to find the area of this triangle here. Okay, well firstly, let's find the coordinates of the point N. We don't know the coordinates of the point N, but we know the equation of the normal. And the equation of the normal is y plus tx is 8t plus 4t cubed. So y plus tx is 8t plus 4t cubed. And we know at this point here that y is equal to 0. So y is equal to 0. So let's find x. Tx must be equal to 8t plus 4t cubed. And we can divide everything by t because t is not 0 here. X would be therefore 8 plus 4t squared. So therefore, we've got our triangle here. Here's the triangle that we're dealing with. I'm just drawing this particular triangle here. This point here is S, and it's 4, 0. This point here is N, and it's 8 plus 4t squared, 0. And this point here is 4t squared, 8t. So it's clear that the height of this triangle, must be 8t, because that's how high this point is here, and the base is the distance between 4 and 8 plus 4t squared. So therefore the area of the triangle is half the base multiplied by the height. So it's a half. Now the base would be this number here, 8 plus 4t squared, subtract 4. That's the base, multiplied by the height, which is 8t. Now 4 plus t squared subtract 4 is, 8 plus 4t squared subtract 4 would be simply 4 plus 4t squared. And if you multiply this out, half times this would be 2 plus 2t squared multiplied by 8t. And if you therefore multiply this out, this would be equal to 16t plus 16t cubed. And that's it, you're done. That would be the area in terms of t of the triangle PSN. Right, next question. Okay, we've got a parabola with equation y squared is 4ax, a is bigger than 0, q is this point, lies on the parabola. Show the equation of the tangent to the parabola at q is the following. Let's draw out a picture. Here's our parabola. We know that y squared is 4ax. Here's our focus, a0, and we know that our directrix is x plus a is equal to 0. We know any point q on the line is aq squared 2aq, and we want to work out the equation of the tangent at q. So, to work out the equation of the tangent at q, you need the point q, which we've got, and you need the gradient at q. So we know y squared is equal to 4ax. Taking square roots of both sides, y is therefore equal to the square root of 4ax. Plus or minus, but I'm just going to take the plus sign here. I've chosen q to be positive x, positive y. So therefore y would be equal to 2. The square root of 4 is 2. The square root of a and the square root of x. And writing that in index form would be 2 a to the half x to the half. dy by dx, therefore, differentiate with respect to x. Remember, 2a to the half is just a number, it's just a constant, it's got nothing to do with differentiating. So you'd have 2a to the half, you differentiate this, you bring down the power of a half, x to the half minus 1, which would be to the negative a half. So just tidying that up, dy by dx, 2 times that half would be 1, so you'd have a to the half, x to the minus half, which would be the same as over x to the plus half. And you want dy by dx to work out at the point x is aq squared. So we're going to sub in aq squared here. We've got a to the half over aq squared to the half, which would be a to the half over a to the half q, and the a to the half would cancel and you get 1 over q. So the tangent is therefore 1 over q. Now, this here, the tangent is therefore 1 over q, so this is equal to 1 over q. Now, I'm just going to rub this out just temporarily. That's how I got the working. So I'm going to rub that out, and I'm just going to show that as the final answer, just so we've got a bit more space to do our next bit of working. So if I go back and come back here. Now I'm going to draw a line down the page and work beside. You should keep working down the page. Let's work out the equation of the tangent. Let's use the formula y subtract y1 is mx subtract x1. We know the point on the line, aq squared 2aq, and now we know the gradient is 1 over q. So let's sub in. Y subtract 2aq is equal to 1 over q, x subtract aq squared. Multiply everything by q to remove the dividing by q here. So I'd have qy minus 2aq squared is equal to x subtract aq squared. And add 2aq squared to both sides, and you would have qy would be equal to x plus aq squared. And it's exactly like we want, but in the working here, it puts the y first. Q times y is the same as yq, is therefore equal to x plus aq squared, and that is exactly what you wanted in this question here, and you've got your 4 marks. Next part, it says this tangent meets the y-axis at the point R. Find the equation of the line which passes through R and is perpendicular to the tangent at Q. Right, to understand this, we are 100% going to need a picture. So, let's take this picture here. Let's draw it here. Now, we are told that the tangent meets the y-axis at the point R. So this tangent meets the y-axis at the point R. So this here must be our point R, where it meets the y-axis. Find an equation of the line L which passes through R and is perpendicular to the tangent at Q. So find an equation of a line which passes through R and is perpendicular to the tangent at Q. Now, think about what this would look like. We have to pass through R and it has to be perpendicular to this tangent. Now, perpendicular to this tangent would look something like that, but it has to pass through the point R, so it would look something like that. Now, what is the gradient? What is the gradient of the tangent? Well, from the previous part, the gradient of the tangent was 1 over Q. What is the gradient of any line that is perpendicular to this? Well, it's the same as the normal. The gradient would therefore be the negative reciprocal, which would be negative Q. And we know a point on the line, x1, y1, well, it's the point R. Now, that is 0 when x is 0, and whatever y is at that point. Now, we therefore need to find where the equation of the tangent crosses the axis here. So the equation of the tangent, let's just write the equation of the tangent again. The equation of the tangent is yq is equal to x plus aq squared. So yq is equal to x plus aq squared. Now imagine I say x is 0. If x is equal to 0, then yq would be aq squared, and dividing both sides by q, y would therefore be equal to aq. So we do have a point on the line. It's R is therefore the point x is 0 and y is equal to aq. So we have everything we need now to work out the equation of the line. The equation of the line is y subtract y1 is mx subtract x1. So y subtract aq is equal to the gradient, which is negative q, x subtract 0. So y subtract aq is equal to negative qx, and therefore y is equal to negative qx plus aq, let's say, leaving it in the form y is equal to mx plus c, and then we're done. That is the equation of the line you're after. It passes through R, this point here, and is perpendicular to the tangent. Show that L passes through the focus of the parabola. Well, we know that L has this equation here, so y is equal to negative qx plus aq. Y is equal to negative qx plus aq. The focus has coordinates a0, so let's substitute that in. Let's substitute y is 0 in, and the left hand side would be equal to 0, and we substitute x is equal to a in, and the right hand side would therefore be negative qa plus aq, which again is 0. Therefore a0 is on the line, and we're done. Part D says find the coordinates of the point where L meets the directrix of the parabola. So let's just quickly get ourselves a graph again just to help us. Here's our graph. Now actually, just modifying our graph, we did not know until part D that this point here actually goes to the focus. So our R, actually we could just move our focus instead. Our focus might be there, let's say. Okay, so this line L, we've just found out it goes to the focus. Find the coordinates of L that meet the directrix. So the directrix has equation x plus a is equal to 0. The line has equation, or we've shown that before, y is equal to negative qx plus aq. So y is equal to negative qx plus aq. From, let's say, equation 1, x is therefore equal to negative a. We can substitute that in 2. So y, we're going to replace x by negative a here. Y is equal to negative q, negative a, plus aq. And y would therefore be equal to, that would be plus aq plus another aq. It would be 2aq. So therefore the coordinates where this happens, well, y would be 2aq, and what would x be? Well, x is equal to negative a. We know that from the first part. So the coordinates would be x is negative a and y is equal to 2aq. And it would be somewhere here. Of course, x is equal to negative a. That's the only point where this line and this line could meet. So negative a, but the y coordinate is 2aq. And we're done. And here's the last question. So we have a parabola with equation y squared is 4ax, a is a constant, the point 4t squared 8t is a general point. Find the value of a. So we know that x is equal to 4t squared and y is equal to 8t. So we can substitute that in here. We would get 8t squared is equal to 4a multiplied by 4t squared. That would be 64t squared would be equal to 16at squared. Therefore, 64 must be equal to 16a. So that tells me immediately that a must be equal to 4. Show that the equation for the tangent to c at this point is as follows. A quick sketch is always helpful. Here's our sketch. We know in this case that a is equal to 4 now. So here's our key point 4, 0. The tangent to the curve at the point, let's say 4t squared, p is 4t squared, 8t. We want to work out the tangent at that point. So we know that y squared is equal to 4ax, but we know now that a is equal to 4, so y squared is equal to 16x. Taking the square root of both sides, y is therefore the square root of 16x. I'm only bothering to take the positive square root because I've chosen p to be positive x, positive y here. So y is therefore 4 root x. Writing in index form, y is 4x to the power of a half. dy by dx, bring down the half, reduced by the power of minus 1, it would be 2x to the minus a half, which is 2 over the square root of x. We want to know the equation of the tangent at this x point here, so we want to work out dy by dx when x is equal to 4t squared. We're going to substitute that in here, and hopefully you'll see it's 1 over t. Now, I'm going to work across the page. You make sure you work down in your workings. We've got, therefore, the gradient. We've got a point on the line, 4t squared and 8t. We use the formula. Y subtract y1 is m, x subtract x1. So we say that y subtract 8t is equal to 1 over t, x subtract 4t squared. And multiply everything through by t, therefore ty subtract 8t squared is x subtract 4t squared. And let's add 8t squared onto both sides, so we get ty is equal to x plus 4t squared, and we've got what we were asked for in the question for our 4 marks. Okay, part C. it says the tangent to the curve C at the point A meets the tangent to C at the point B on the directrix of C when y is 15. Find the coordinates of A and the coordinates of B. Okay, so let's draw out a picture for this. We have our curve like this. We know that the focus is 4, 0. We also know that the directrix is x plus 4 is equal to 0, or x is equal to negative 4. So I'm just going to do that in a different coloured line. Let's just call that x is equal to negative 4. Okay? With the tangent to the curve at the point A meets the tangent to the curve at the point B on the directrix when y is 15. So over here somewhere, we've got negative 4 and y is 15. And we've got that two tangents meet at that point. Now, how could that be the case? Now, it could be I've just drawn my parabola slightly shoddily here. The parabola is probably a little bit more like this, that type of thing, and maybe this point here isn't so high up looking, it's somewhere like that. Okay, now we've got two tangents meeting at that point. Maybe one tangent looks something like that, and maybe the other tangent looks something like that to meet at that point. Okay, now we are told, don't forget what we've done in part B. We've told that the equation for any tangent is yt is equal to x plus 4t squared. So yt is equal to x plus 4t squared. That is true for any tangent. And we've got a tangent 1 here. I might call it tangent A because that may be the point A. And we've got a tangent B here because maybe that's the point B, let's say. And we know that both those tangents meet at this point here. Now, we know these are the equations of the tangents, and we know one point they both go through. X is negative 4, y is 15. So let's substitute that in here. Let's substitute negative 4, 15 in. We would get 15t is equal to negative 4 plus 4t squared. And subtracting 15t off both sides, 0, I'm just going to rewrite this. I'm going to say 4t squared, subtract 15t, subtract 4. Okay? And now let's try to factorize here. 0 would be, let's try and factorize as 4t and something like that. 4t, let's subtract 4 here and maybe a plus 1 here. So therefore t is equal to 4 on one hand and t is equal to negative a quarter on the other hand. So we have found the two t's that are appropriate here. So this t here, t is 4. This t here, t being 4. And this t here, t is a quarter, is appropriate for this one. And t is 4 is appropriate for this one here. So all we've got to do is substitute t is 4 and t is negative quarter back into any point on the line, 4t squared 8t, and we've got the coordinates. So any point on the line, let's remember, is 4t squared 8t. Okay, so therefore A, when t is 4, we're substituting that in, is therefore t squared is 16 times 4, so be 64 multiplied by 8 times 4 be 32. And B would be when you substitute t is negative a quarter in here, where you get yourself, if you just substitute that in with a calculator, you would get a quarter and you would get negative 2. And they are your points A and B, and you're done. So thank you for watching this video. I hope you found it useful in your revision.